suppose that the temperature at point x, y, z is given by the function t of x and y and z, where x and y and z are in meters and t is in degrees Celsius. Suppose that partial respect to x of t at a and b and c is given by -2. Partial respect to y of a and b and c is given as 3. Partial of respect to z of t at a and b and c is equal to 1. At which direction and at what rate does the temperature increases fastest at a and b and c? The rate of increase is the fastest in the direction of the gradient vector. Gradient vector at a and b and c is given to us by -2, 3, and 1. And the rate of change is basically the direction vector. That's the directional derivative of t in direction u, where u is the unit vector of the gradient. So let's see. First of all, I need to compute. So this can be considered as direction, but also you want to find the unit vector for that. And so the magnitude of t at a and b and c is equal to square root of -2 to the power 2 plus 3 to the power 2 plus 1, and that is 4 plus 9 plus 1, and that's square root of 14. So basically this is going to be the rate, the fastest rate. If you want to make sure that this is in the unit vector shape, you write it like this. And that helps you remember that directional derivative in this direction of t is going to just be the magnitude of t, basically. And that's kind of helpful in there. So the answers were that this or this are the directions, and that one is the fastest rate of change. Now, in which direction and at what rate does the temperature decrease fastest at A and B and C? Now, the answer to that is the negative, the gradient vector t at A and B and C. That is 2, -3, and -1. And or you can write it as 2 over square root of 14, -3 over square root of 14, -1 over square root of 14. So the other question is, what is the fastest rate and fastest rate of decrease? That would be negative square root of 14, or negative gradient vector, the magnitude of the gradient vector. So that was the magnitude of the gradient vector that was fastest rate of increase. And the fastest rate of decrease is the negative of that, basically. So that's the rate. This or this are the directions. Now the last question is asking, what direction does the rate of change? In what direction does the rate of change of temperature equal to 0? So we know that in the direction perpendicular to the gradient, the rate of change is going to be 0. But what are the directions that are perpendicular to gradient vector? That's anything that is in the tangent plane, basically. So I can write it as gradient of t dot u and v. Let's not call it u and v, let's call it u1, u2, and u3 equal to 0. So anything with that property would be true. What is that? That's negative 2u1 plus 3u2 plus u3 equal to 0. Give a few examples of this. There are infinitely many vectors and that can lie on that tangent plane. And let's just give a couple of them. I can plug in, let's say 0 for u1 and 1 for u2. So I get 0, 1. And then if I plug in 0 and 1 in there, it would be 3 plus u3. So u3 has to be negative 3. Now I can switch that and plug in 1 for u1. So I get negative 2 plus 0 for u2. And then I get negative 2 plus u3 equal to 0, which gives, 2 as the third variable. So there are infinitely many, so I can choose 2 of the variables, whatever I want, and solve for the third one and get the vectors.